the main thing that an architect does is decisions. They said, no, we have other vendors. And I might have been responsible for that loss of business. You can't rely on an LLM for anything.
This is a conversation with Avraham Poupko, a professional system architect, mentor, teacher to other architects, and keynote speaker. We discussed the nature of making software architecture decisions, how large language models help with that, and we share the stories about our failures as architects. I hope you will enjoy this interview. And if you do, don't forget to smash that like button down below and write a comment with your stories about software architecture.
I've been an architect for a long, long time. I have been a teacher of architect. I lead a group of architects. And one of the things that an architect does, I could even argue the main thing that an architect does is decisions. He makes lots and lots of decisions. He makes correct decisions, and occasionally, or more often than we would care, he makes incorrect decisions. And when we say an incorrect decision, we mean a decision that is not, that if implemented, the outcome is not optimal. A decision that if followed, we might end up having a system that doesn't perform as well as it should, or doesn't even do what it should, or is not flexible in the right ways.
You said incorrect decision. What does constitute a correct or incorrect decision?
A correct decision is subject to debate. So I'll offer both interpretations or both definitions of a correct decision. The audience will have to decide for themselves which one works for them. One definition of a correct decision is, given the evidence and the current understanding, the most reasonable decision. And if you do that, you made a correct decision, even if the outcome was bad or not optimal. Another definition of correct decision is a decision that stood the test of time, that as the decision unfolded, it turns out to have been an optimum decision. Now, if I use that definition, which I find better, you will not know if a decision is correct very often until decades later, if you decide to put a particular kind of flexibility or a particular kind of interface or a particular kind of implementation, it could go by for years without it mattering one way or the other. And then a couple of years later, maybe 10 years later, you realize, oh, that was a good decision. We now have the flexibility needed in order to be able to do something. I'll give an example from the life of a software developer. I have to decide, do I have one function that does A or B, depending on the value of a third parameter? Or do I have two functions? I have functions saying implement A and implement B. And first of all, it depends, does the caller know which function do they need to call? Do they need to call A or B, or does it depend on another environment? And it depends on the expected evolution of the software over time. And it expects on how important ease of reading is versus ease of writing. And it depends on how similar behavior A and behavior B are to each other. And when I say how similar are they in code? How similar are they in behavior? And the programmer has to imagine all these things, has to take into account all these things and decide, is she going to write one function with two variants, or is she going to write two variants of the same function? And she might not be validated in her decision for a long time.
Yeah, it also depends if the option C is emerging in the nearest future.
Yes, excellent point. Excellent point, Vladimir. Do we expect a variant C to come on? Do we know what that variant C will look like or not? And then if we're going to expect a variant C, D, E, F, G, then I might need something else entirely. I might need some other way I might need an array of pointers to functions or something like that. And I could decide I don't know. And I could decide to leave in a certain flexibility and then later on to decide. And that has its own cost, because every time I leave in flexibility, the code becomes a little hard to maintain. So if, as an architect, we decide to put particular flexibilities in the code that are ultimately not needed, we made the code more complex than needed, and we ended up not getting the benefits of it. Flexibility makes the code a little more brittle, a little more fragile. It breaks easily.
What stands for this period of time that we're evaluating our decision against? Is it like 1 year, Is it like the lifetime of a person, of an architect in the company, or it spans across like decades?
It might depend on the architect. So there is a particular architect that says, I don't want the decision to be found wrong in my lifetime or in my career or in my working in the company. And it
Hmm.
might be an architect that says, I don't want the decision to be ever proven wrong. Or, we're right before elections in the United States. Presidential candidates often say, as long as it doesn't go bad in my term, I'm okay. I don't mind if I make a bad decision and it goes bad in somebody else's term. In English, in American English, we sometimes call that kicking the can down the road. And if you kick the can down the road far enough, it's okay. And there might be an architect that will say, I want to make the best decision possible so that even in 20 years, towards the end of the lifetime of this software, it will still, people will look back and say, wow, that was a good decision. That was a solid decision, ended up proving to be resilient.
What do you think about such attitude? Is it like even viable in our modern environment where like the tech stacks are completely changed across a period of 10 years?
There's a saying in shipbuilding, I don't know if it applies to software. As the ship lives on, we replace the sails, we replace the anchor, we replace the mechanics, we replace the engine. As long as there's one nail from the original shipyard, it's still the original ship. So, what
Okay.
do I think about rebuilding software is constantly being refactored at many, many levels. That is true. But very often there are some structural elements that stay there throughout the life of the software. And that also drives the value of the decision. Am I in a culture where the software is constantly being rewritten and rewritten? And in that case, I don't care for its resilience over the long term. If I expect my house to be painted every year, I won't do such a good job on painting because next year, if I miss a corner, if I miss something, or if it's not the right color exactly, then I'll paint it again the
Mhm.
next year. If I'm now going to be painting something that's going to be staying painted for the next 20 years, I'll be very specific. I'll pick exactly the right color, the right kind, the right. It really depends on the particular project, the particular culture, and some things about software do last a very long time or can last a very long time.
Excuse me, but I find this analogy slightly inappropriate because we're not expecting the houses to grow bigger and bigger each year, first of all, compared to businesses who I expected to. That's first thing. The second thing is that when you're painting the house, it's just the cosmetics, right? You're not changing the structure of the house itself.
That
So
that is a
it's
good point.
kind
Yes,
of
maybe that wasn't maybe so. The example doesn't need to be good. One of the things that architects decide is one of the decisions that architects make is what metaphor do they pick in order to make a point. And sometimes they make a bad decision and they admit that was a bad metaphor. And then they go on and they pick a better metaphor next time because metaphors
okay.
can stick around for a long time. So yeah, I accept that. Here's an example of a bad decision.
But still, how like getting to the point when we say, okay, architect doesn't want to the decision that they made to they wanted to stick around for the at least for the time that they are in the company. Is it still viable? Imagine a person spending 20 years in the company, and this is not like very rare case. But then, like only on the last 10 years, like we got serverless, we got the complete migration to containers, right? So nobody's deploying jars anymore into virtual machines. It's more like still containerized and so on, and it's cloud environment. So the way how we used to deploy software changed like almost completely.
Well, we see that the deployment models are constantly changing. So no decision I make will last more than a year. I'll just decide for the horizon of the year. I'll decide to go monolith, or I'll decide to, because within the next year, monolith makes sense. And then later on, who cares
Hmm.
about later on? Later on, things are going to be so different that any decision I make will probably be irrelevant. That might open a door to irresponsible behavior or into not thinking long term. You might be right. I don't know. I got to think about that a bit. The world is so dynamic, is so flexible, and maybe it really depends on the nature of your work. I'm a software architect, but maybe somebody that's designing, or a system architect, maybe somebody that's designing hardware has a different view of the world, of the cost of decision making.
Hmm.
I'd imagine that somebody designing a compiler or a language, they might need a longer term view than somebody designing a mail order system for ordering lunch. Because the mail order system, especially with modern deployments, is in constant flux. It won't be the same next week as it is today, and certainly not next year or next decade. But if I'm designing a compiler that's going to compile my C++ better, or going to compile a particular implementation of C++ for a particular platform, it might need long-term thinking. You know that people that design pacemakers design a combination of hardware and software that will not take an update, hopefully, for decades to come, right? We want the person to live a long time. We don't want him to go through an upgrade. And if we decide, it seems like a good idea to deploy the pacemaker using containers or using microservices, because it might be a real bad idea. So it might
I can imagine a nightmare, like a person having a notification on his iPhone that they need to have an OTA update for their pacemaker.
exactly. They need to have an upgrade or a replace, or there's been a bad hardware. Now, one of the things about decisions that comes up a lot is, first of all, who decides, or when do we decide that there is a decision to be made? It's like the meta decision. And then, so we decide that there is a decision, and we decide who makes the decision. And there's a lot of power there. And decision to be made here. Let's get all the relevant stakeholders, let's say. Stakeholders means not somebody who has an opinion, but somebody who has a stake, somebody who's going to have to bear the cost of the consequence. And let's put together a stakeholder meeting, and each person will say his or her preference or his or her value. And in democratic, I might say each one gets their own vote, or I might say it's autocratic and each one gets a say, but I get the vote, or some other ranking or decisioning system. I might not bring in a stakeholders meeting. I might bring in a think tank. What is a think tank? The difference between a think tank and a stakeholders meeting is a think tank are a bunch of people that do not have a stake in the system. They're independent thinkers or independent consultants, but they have different perspectives or different experiences. So if I have to make a decision, I might bring in a person with a lot of experience in microservices, a lot of experience on containers, a lot of experience on big systems, a lot of experience on small systems, a lot of experience on legacy systems. And I might say, okay, here's my decision. Let's talk and discuss it. Think tanks are very, very expensive. You need people with a lot of experience. The meetings could go on for a long, long time. And they by their nature, they often tend to broaden. They're not very focused. Stakeholders meeting can be very, very focused if there is a good discipline of meetings. So, and it's very often the architect, not always, but very often the architect or VP R&D or head of development that decides there is a decision to be made here, and let's distribute the decision, or let's make it with other people in mind. And then if it goes bad, the architect could always say, well, I called in the stakeholders meeting. Everybody had an opinion. We decided based on the majority. It's not my fault. But that's not really true. Had he been good enough at seeing the future, the architect would have presented the options and maybe would have made a good decision.
Do we talk about some huge decisions that affect the whole company, or we're talking about the decisions in each team, in each development team? So let's say we have a team, we have 5 microservices under our responsibility, and we're making a decision, like for example, to transition from MySQL to Postgres or backwards, or I don't know, go.
The decisions that I was referring to were the structural or architectural decisions. The business decisions, the architect does not decide. The architect has input for the business decision. So if we say we are going to make a business decision that we have to be able to scale up to 1 billion users within a week, and then we might have to scale up to 1 billion users within a week, and we don't know when the week starts. It might be the week before Christmas, it might be the week before next Christmas, or it might be the week before the following Christmas. But there's going to be a week in the lifetime of our system where we have to scale up or we might have to scale up very, very fast. So the job of the architect is to have a meeting with the business owners and say, This is the risks and potential with different possible implementations or possible directions. And then, like, we might say, let's go cloud, let's go microservices, let's go auto scaling. Now, exactly how do you divide it into the microservices and how do you implement auto scaling? Once the business decision has been made to have an auto scaling system and to go in cloud and to go microservices, microservices might be a part, at least in part, a business decision because it affects the way the business scales its software or its service. So that's a big decision where the architect does not decide. The architect does not have authority. The only thing she has is input to the other decision makers. And in order for that, the architect has to be a very, very good communicator, has to have some sort of business acumen, has to understand how businesses are run and how architecture affects the viability of the business. And he has to be able to speak both languages. That's one of the things that an architect has to be able to do, is be able to speak the business language and be able to speak the technical language. He doesn't have to be a very, very astute or acute business person. There are business people that are better at it than him. And he doesn't have to be an amazing hands-on Python developer or code developer. But he has to understand deeply the dynamics of the code, and he has to understand how business works. And he could support the business in making good technical decisions, and he could support the technology in making and support the technology in supporting the business.
So we basically divide the decisions in the company for the technological or architectural ones and business ones. Do we need to ask ourselves every time, is it like a business decision or architecture decision?
No, but we do need to ask ourselves, what are the impacts of this decision? Maybe it's the same. We need to ask ourselves, does this decision affect the business? Which all architectural decisions ultimately affect the business, but does it affect the business requirements? Does it affect our ability to offer service, or does it affect our ability to scale? We have to understand the implications of our decision. So there might be decisions that affect our ability to offer service. There might be decisions that affect our ability to code efficiently. There might be decisions that affect our ability to go into other areas of technology. There might be decisions that affect our ability to quickly bring in new developers. There might be decisions that affect our ability to be merged or to be acquired or to be integrated with other third parties. And the architect has to know what are the implications. Some of those are business, some of those are technology. Many of them are both, of course. Technology and business are not tightly separated, they're loosely separated. And part of the art of decision making is to understand the implications of the decision we're about to make.
How deeply the architect should be involved into this business stuff and have this business context in order to make or consult on these decisions? Or they should focus only on technical stuff?
It depends on her position within the organization. It depends on the nature of the organization. There is a difference between an architect and other disciplines in that sense. A programmer, for the most part, their job is to write, debug, and maintain code. If I want to take it to a higher level of abstraction, the programmer knows how to convert requirements into commands. So you tell me what you want the business to do or what you want the system to do, and I know how to write that in C or Python or C++ if I'm a good programmer. So you told me what you need, I know how to write that in C++. I know how to translate your requirements into commands to the computer. Programmers do not spend an awful lot of time or an inordinate amount of time discussing what it is that a programmer does. A lot of programmers understand what they do. The excellent programmers understand it, and the programmers that are still on their path understand intuitively what it is that a programmer does. Architects spend an awful lot of time discussing what it is that an architect does, to the point that I might say it's part of the job of the architect is to define the job of the architect. It's to spend time thinking about within the organization, how do they maintain conceptual integrity? How do they involve themselves? How do they contribute? And it requires awareness of one's own personality, one's own inclination, one's own ability to influence, the software within the organization. So, does the architect get involved in big decisions or small decisions? Does the architect get involved in business decisions or technical decisions? And what scale? It really, really depends on the role, the abilities of the architect. One thing that an architect needs in order to be effective at her job is to be aware of her own abilities. So if an architect thinks I have broad view and I know how to make very complex decisions, and they don't, because they don't have the breadth of view yet, or they don't have the experience yet, that could be bad. That could be very bad. On the other hand, if an architect thinks, I'm just a small architect, I only know how to decide how to divide code into modules, but I don't really know how to decide microservices versus monolith or auto scaling because I'm not so smart. And they are, there's a real missed opportunity there. So an architect needs to be, now it's in general, it's a good idea to be aware of your own capabilities because that allows you to be more effective at what you do. We all need a mixture of self-confidence and humility. Self-confidence means aware of what I can do and belief in oneself. And humility means aware of one's limitations and what they can't do. And we all need, when we say we, I mean all the human beings on the planet need that mixture. But architects need it too. Architects need a good mixture of self-confidence. I know what I could do and I know what I could do it well, or I know what I could learn and then I could do it well. And I know what I simply can't do. And then I'll let somebody else do it rather than do damage to the system. Because rarely, no, architects don't always get lucky. So if you do not have the skills or the knowledge to make a good decision, chances are that fast enough you'll make a bad decision and it'll come to bite you. You're not going to be able to remain lucky for a long time.
How an architect should evaluate their abilities? For programmers, it's pretty straightforward. You write the code, it either works or it doesn't, right? But how to do that for the architect? Like how to find these boundaries and limitations of your ability to design systems?
Was never asked that question, so I need a few moments to think about. How does an architect evaluate his own abilities? I said it's important, so that means there must be a way to do it. Because it's pointless to say it's important, but I don't know how to do it. That's not helpful. Well, I'm thinking aloud. And, Vladimir, I have no advantage over you in this one. So if you have other ideas, please teach me. An architect should listen to other people around him. If people around him tell him this was a good decision, you earned our trust, you did well, and the decision, you were able to provide convincing arguments, and you were able to explain the trade-offs well, and you were able to give us confidence that you know what you're talking about, I guess that means that he's capable. And if the people around him say, we understand the decision, but we don't feel so good about it, and we're not confident in it, and we feel a little shaky about it, then the architect knows that maybe he still has something to learn. Because an architect knows how to evaluate other people's trust and other people's behavior. An architect knows how to understand how resilient a system is. So if I make a decision, then a year later, there's a big change that comes into the system. And the change just slides in well. I've earned the right to pat myself on the back and say, you see, Avram, you did well. You made a decision and the decision came in. Now, I might be wrong. I might have just been lucky, but architects don't get lucky all that often. So, and conversely, if I made a decision and then a year later, there was a change to the requirement, and the change was much more painful than it had to be because I made a bad decision or a bad call. I have to be mature enough to admit it, to admit to myself and to admit to my surroundings. Yeah, that was my decision. I decided to go monolith because I thought it was a good idea at the time. And I guess I could have known, or I should have known, that it was a bad idea. And now apparently it was a bad idea. I'm a lot smarter now. But yeah, I made that mistake, and it's not easy. It's not easy to admit one mistakes. People equivalently compare or equivalate making mistakes with being incompetent, and sometimes that's true. But so it's not easy for us. It's not easy for anybody.
Here's the catch: an architect can always say that, hey, this new change doesn't apply well to my architecture because it's a completely different business requirement. Okay, like the business landscape changed, so now we're doing a very different thing, so that wasn't my bad. It's like the world changed. And it's very, very slippery road when you can tell yourself like every bad decision was like, hey, nobody can predict the future.
Yes. And that is part of what honesty and maturity is. Sometimes he might say the decision was a good, solid, responsible decision that balanced risk and opportunities, and just something unpredictable. When I say unpredictable, not mean something that I didn't predict, something that by its nature is unpredictable happened. And it happened. And since it's unpredictable, that means next time I won't be able to predict it either because it's unpredictable. But don't do that as an excuse. Don't do that in order to save face. Do that because it's true. And sometimes it was predictable. It's just that I didn't predict it because I wasn't experienced enough or open-minded enough or curious enough or whatever it was. Slippery slope.
Do you have any examples from your experience when you made such a decision because you like was not wise enough? I don't know.
I once worked in the area of pay TV, television, and we designed a graphical interface for the television. And one of the things that the graphical interface allowed was for what was called then DVB subtitles. It allowed for a certain kind of subtitles to show across the screen. And the requirement was for all the Norwegian languages. So we had to put in all the characters in all the languages to be supported by the middleware. And I, for some reason, thought it was a good idea to also add in right to left languages, Hebrew and Arabic. Who knows? Maybe one day the business will expand. One day the markets will change. Let's put in also right to left languages. And I spoke to the business people, and the business people said, well, the truth is we're limited to Europe and to Scandinavia and to the Baltics. All the languages there are left to right. But if it's easy and it's not too complicated, who knows? Business one day might change. And I applied all my charisma and I convinced everybody. I said, here, we're designing the modules. Let's also add. And we added to many of the functions the RTL or LTR function. And there was a lot of resource and a lot of testing and a lot of bugs and a lot of all kinds of stuff. And the annoying bugs are the kind when the English starts presenting right to left because some flag was misdone or something.
No way. I can imagine.
You fix it. And we finally ended up the system to get working. 15 years later, it was time for a major upgrade because everybody started going to the internet and people stopped using that platform. Never used a right to left language. Nobody ever needed it. And had I been smarter, and it cost a lot of money and it cost a lot of development, and there was a team devoted to the right to left languages. None of it was ever needed. And had I been a bit smarter about things, I probably could have said, let's put in some sort of hook or some sort of variance so that if a right to left language ever comes aboard, we'll be able to implement it and support it. But to support it at the graphical layer might have been a bit overkill. And when ultimately the customer, when they decided to go from set-top box to go to internet, and they turned off their set-top box offering, and the company I worked for, applied to do that work, they said, no, we have other vendors. And I might have been responsible for that loss of business because we were a bit slower and we weren't as agile, and we implemented a great feature that nobody needed. So that's an example, a painful example.
Yeah, this is a very good story. I liked it a lot.
And I'm sure as I'm talking, if there are architects listening to this podcast, which I hope there are, it'll resonate with them. Yeah, we've all made that kind of mistakes.
Yeah, folks who are watching us right now, leave a comment down below about like the technical story where you made a wrong call and what was the consequence to the business. I'm really curious. Thank you. All right, yeah, I have a similar bunch of stories where we're designing a messenger app when WhatsApp just became rather popular, and we were focusing on the security a lot, and then we went bankrupt because we were focusing on the wrong thing. So we had to either market the messenger as a very secure or not focusing on this in the first place because it was like our latest concern at the moment. So yeah, how do you make the decision to transition to some other technology? Like, what do you evaluate? What artifacts do you create? Like, how do you weigh this pros and cons? Like, how it should happen?
Okay, excellent question. And that is a question that I've been asked before, so I know the answer. Though the answer does change every time I give it. But yeah, that's a good question. So again, there's a need for a technology change because something about the business um, changed, and there's a decision to be made. And the decision is, let's say, but for without any loss to generality, as the mathematicians like saying, let's say that the options are stay with the system and find a way to either live with it or scale up the current system, or replace the system with system A, or replace the system with system B. So I would first of all try to write on a notebook, and the thing on my notebook is, this is not a document yet, is all the trade-offs that I need to consider. What do I need to consider? Do I need to consider the flexibility of the system, the scalability of the system, the security of the system, the future evolution of the system? One thing that I consider a lot are the abilities and the wishes of the development team. It matters. If the team decides we want to learn microservices or we want to learn message queue, it's a good idea for us. We've never done anything in Kafka or Rabbit, and we want to get that experience. We've never done anything in cloud. We've never done anything in hybrid. That is not the only consideration, but it is most certainly a consideration, because people will do well if they're doing something that they're learning from, if they're doing something that's curious. I have to consider how well we know it already. So if we have experience in microservices from elsewhere or because from a previous project, that's a point for microservices. Is this a company that has a security concern? Is this a company that has regulatory concerns? Do we operate in the medical field or in the security field? Is this do we understand the future requirements, or did the system say the system has to perform faster? That's it. And that's always not a clear requirement. If they said the system has to perform 2.5 times faster, instead of a query coming in within 10 seconds, a query has to come in within 4 seconds. And instead of us supporting 10,000 users, we have to support 150,000 users. Or something that's more quantifiable. It makes the decision different than if the business says our system is performing too slow, customers are unhappy, we have to perform faster. Then I might not make an architectural decision. I might make a research decision and saying, okay, the system is performing too slow. Let's find out where the bottlenecks are and see if we could do some local improvement to the bottlenecks. I will make sure that I understand the business needs. And here is where domain-driven design principles come into use. Because I speak to the business people, and I speak to the business people in their language. And language is very, very important in understanding the business. And language, of course, is not just about vocabulary, using the right words. For instance, do you say user or customer or person or end user or login? Use whatever words the business uses. That helps you be more understood. So if the business consistently says client, but you like using the word user because that's what your code says, you'll end up somebody's going to have to constantly make the cognitive translation between the two. Use the words and use the structures between the two. So if there's a certain relationship between the client and the account and the device and the payment method, make sure that you and the business owner agree on how that relationship works between the three. And if it works, you'll have your better conversation. You start mapping out the options and never be fixed on the options. Always consider the option that there's another option that I hadn't thought of yet, and that somebody else might think of it. So if I'm about to scale the system and I'm convinced my two options are either point-to-point communication or message queue, because that's the limit of my imagination. Maybe I need something else. Maybe I need monolith. Now, monolith has a bad reputation, but maybe for this particular problem, monolith will work. So maybe I need some hybrid of point-to-point and message queue. Maybe I could stick with the current system and just replace the subscription module, and everything will be fine, given the budget constraints and given time. I have to be aware of cost. I have to be aware of complexity. And I have found, as I mentioned in the talk that I gave in GSAS a couple of weeks ago, that when it comes to evaluating trade-offs and it comes to articulating trade-offs, the LLMs, the AI, large language models, modules, can be helpful. You can actually get GPT or Claude or Gemini or Cohere to help you evaluate trade-offs and help you. Cohere is never, I don't know, never, but in the near future, Cohere or GPT or Gemini are not going to be architects. I'm going to be an architect, but they will help me. So that's how decisions are made by considering trade-offs.
Yeah, so basically we're talking about understanding the trade-offs that we have from different options that we have. But in order to come up with those options, you need some experience as an architect. Like, hey, I saw this situation before. Those are the options that we have, right? So they should be aware of, I don't know, different database types, aware of different offerings from cloud and like on-premise providers, be aware of the trade-offs and the applicability of the particular database engine to the domain that they're using, because again, you mentioned regulations, right? So those are complex things that you need to have experience and knowledge of to like lay down the options in the first place. But then I agree a lot about these LLMs, that they can be very helpful because like they have the knowledge of the whole internet basically, so they can help you align on these trade-offs. But you need to check like whatever they're generating if it's true or not. And
Yes,
this
you
is
need to
again
be
where
very,
your
very careful.
experience.
So when it comes to experience, yeah, it's hard. That's a tough one, and I don't have a perfect answer. I'll tell you what works for me. Mentoring or coaching. It's a very, very useful tool for the architect. So if there is a developer or an integrator or a QA person that shows the qualities that you think an architect would benefit from, or the qualities that an architect needs. They like system thinking, they understand complexity, they understand trade-offs, they have the good combination of humility and self-confidence. Then maybe you should mentor them and saying, come to my room, I want to talk to you for a few minutes. This was the decision that was made, and I want to share with you some of the trade-offs that I considered. And if you're right about it, she's not going to say, oh, that's not interesting to me. I'm just a QA person. Let me go back to writing my QA. She'll be unbelievably flattered and say, yeah, wow, thank you. Thank you for teaching me that. Thank you for sharing that to me. And she might even actually offer something insightful. So one of the best ways to find architects, architects are hard to find. Good architects are very hard to find. So the best way to find a good architect is to make one. And you make one by finding a competent programmer, a passionate programmer. Energy is very, very important. Architects can't afford to be tired all the time. So you need somebody that's energetic, that's curious, that reads new things, that likes knowing new things, that finds that if they are an effective teacher to add, that's also great. Not a must, but it's really nice to have. And then you raise them, you mentor them, you cultivate them. And I've done it many, many times. I found developers or IT engineers or DevOps people that really had the system-wide thinking to become an architect, and I mentored them in becoming architects, and they became very, very good architects. And I'm very, very proud of all my mentees and good friends with all of them, even though we've all moved on to different companies. And one of the things we learn as senior people, now this is a management thing, not an architectural thing, but since I have the mic, I might as well say it anyway. The good managers get their power from pulling people up, not from holding people down. The bad managers try to hold people down because they see other people as a threat on their careers. So any manager that's listening to this, don't hold people back. The best thing you can do as a manager is pull them forward, is push them forward. And if one day they become smarter or more senior or more accomplished than you are, that's all the better for you. That means you've done a great job. Never hold people back. Never hold people back. It's wrong. It's malicious. It's bad. It's bad business and it's bad personality.
Yeah, I agree. This is the wrong attitude in the first place, right? So the more powerful people become, and if they have this loyalty to you and the gratitude for helping, they will help your career in turn. and you never know what are the opportunities that will be created in the future that
Yeah.
you could leverage. So
And never ask
yeah,
yourself how many people report to you. That's not an interesting question to measure power.
yeah,
Maybe ask how many people have you influenced. That's a good question.
yeah, yeah. How many people you can help exactly? Okay, I have a question about this mentorship. So, what were your like biggest problem while mentoring engineers into architects? What is the most complex problem you would see there?
The experience gap. It's something that I struggle with and I still struggle with. I am an architect with quite a bit of experience. They are an architect with
Hmm.
little or zero experience. And the
All right.
good teachers know how to imagine what the world feels like to a person that doesn't have that kind of experience. So, without sounding over hubristic or whatever the right word is, imagine a professor of math teaching first grade arithmetic. His biggest challenge will be, how do I get the theory of mind? How do I step into a mind of a 6 year old trying to understand the difference between a number and a numeral and a value and a count? And what's the difference between what do all these symbols mean? Because it's already part of my DNA, it's already deep into my structure. So when I mentor young architects, one of the things I struggle with a lot is, how do I imagine the world from the perspective of somebody that doesn't have the world experience, so that I could explain it in their terms. Now, I'm a good teacher,
Hmm.
so I have it, but still I struggle with it. I still struggle with it. That is one of the biggest challenge. The other challenge is the organizational challenge, by which young people often, or people that are young in their careers, it's not always the same, often have their times managed by their manager. They're not really fully autonomous of their own time. And their manager wants them to hammer out code. The manager doesn't always want them to learn about architecture. That's a long-term investment. And that's usually a discussion that I have to have with the manager and say, manager, invest in your people, invest long term investment in your people. That's how you get loyalty. That's how you get good people. That's how you get curious people. Even if she's going to learn something that'll only be valuable in 2 years or 3 years or 10 years, it's a good investment. People want people that you invest in, will trust you, will do a good job, will progress along the way. So if I had to say two challenges, the challenge is getting the theory of mind and being able to bridge the experience gap, and the experience of getting management buy-in. I do not have a challenge of people not wanting to be mentored. That's not a challenge I face. Very often, if you call a young developer and say, let me teach you something, or I want to work with you through a problem, they're always eager to do that, especially since I recognize deeply these people have a lot to teach me. They have a lot to teach me. So there's really a lot of mutuality in it. So when I go to a young developer who's a devil of a Python programmer and who's really, really good, and they understand the Python language model and they understand the libraries and they know how to write real good Python code to the extent possible, but they don't know structured thinking or system thinking. And I could teach them a thing or two about system thinking or trade-off thinking, and they could teach me about a Python library or how things should be done or could be done. There's a mutual exchange there that's always valuable, always beneficial. And when people learn together, they become friends together, and it's a rewarding and satisfying relationship.
Yeah, it's a great attitude towards mentoring. Not only thinking about yourself like I'm the older, more experienced guy, I'm gonna teach you everything, but actually be open to the feedback and to other perspective, and be open to this opportunity to learn how it feels like for another person, like grew in a different environment, having different work experience, and facing different problems, right? So
So, since you mentioned that, I'll be even more specific. The more mature and the more experienced of us, what we bring to the table is, we've made a lot of mistakes. We've admitted we're not so concerned about our career, because very often for a lot of us, the peak of our career is behind us, and now we just want to do good work and do exciting work, and we're not that obsessed with the next promotion or the net or how many people we manage or what is our boss going to think about me. So that's what the more mature thing people bring. The younger people, they bring to the world an unbelievable amount of optimism, an unbelievable amount of belief in the future, curiosity. They're not fixed in their ways. They're willing to try new things. They're willing to experiment and fail and experiment again. It's almost like watching a little child learn how to walk or learn how to get a skill. If I had to learn to walk that way, I'd just get up and say, I'll just sit down because it's too hard and the failure is too painful. And we have to learn that from the younger developers. So anybody that has a chance of learning from younger developers or less experienced developers, how to be curious, how to be willing to try things even after you failed, how to be willing to learn new things, do that. Do that. It's rewarding.
Yeah, exactly. Exactly. So I also find that the young people are extremely energetic and passionate, so they need to do something, that very curious, and they're like ready to work a lot. So yeah, that's something that I already miss, and I'm not that
Yeah,
old. At least I think
yes,
so.
and maintaining that
But yeah,
energy.
let's talk back about this LLM stuff.
Sure.
So can we really rely on the decisions that these LLMs help us, and
No.
what to be aware of?
Okay. You cannot rely on a decision that an LLM is aware of. You can
Okay.
rely on an LLM. You can't rely on an LLM for anything. The LLM will present you with options, will present you with trade-offs, but you, the human, is ultimately accountable. You, the human, are the one that has to consider the trade-offs and cherry pick and use it. So if I say to the LLM, I offended my partner, help me write an apology letter. It'll write me an apology letter, but I have to review it and make sure it's relevant and that there's nothing offensive there or nothing too coarse or whatever it is.
Hmm.
And it's my responsibility. If it ends up being a bad apology letter and offending more than it helps resolve, I can't blame it and say, well, the LLM told me to do that. That's a very lame excuse. That's a lame excuse. The LLM told you. The LLM didn't tell you. You're an adult, and the LLM is just a tool. So that's one thing. LLMs do not make decisions. LLM help weigh weigh trade-offs. Um, it helps in this context to think about a book. I haven't written a book, but I've written many articles, and there might be people on the podcast that have written a book. So the way we write a book is as follows: we gain a lot of experience from all kinds of cases. We then spend a lot of time thinking about what about all my experiences can be abstracted or can be common or can be written into what developers might call a pattern. And I write a book, and the book might be a pattern book or the book might be an abstraction book that explains how to do things. So I go, it might be called induction. In logic, we have induction and deduction. So this is the induction phase
Hmm.
where I have many, many cases. Based on the cases, I come up and now I have a book. Then the book goes to the person that reads the book. They read the book and they understand the book, and then they understand from the book how to apply it to their particular case. That's called deduction. So the author of the book
Hmm.
took his experience into the book. The reader of the book took the book into his own experience. If you want somebody to apply their experience directly to your very specific problem, you hire a consultant. If the book is not enough for you because the book is too generic and you need something specific, you'll find the book author. You'll see if she offers a consultancy. And if she does, you'll say, could you come look at my very specific problem and apply your experience to
Hmm.
our problem? That's what consultants do. Consultants, why don't consultants just all write books? Besides the fact that they need to make a living, is because it's not easy to apply the experience of the book to the individual case. Now, all the LLMs have been done is they've been trained on everything that all the smart people wrote or all the stuff that was written about the smart people. So most of what the LLMs have in them is what has been written by the smart people and what has been written about the smart people. But most of what is written by and about the smart people is generic, is abstractions. It's not specific. And the LLMs do not know how to reason. They do not know how to apply their broad experience to a specific case. I know how to do that. I know how to take everything I learned and apply it to a very specific case. It might sometimes be called reasoning or application. So you use the LLM just like you use a book. If I can't apply the book directly to the problem at hand. I need to use my brain to apply the wisdom I read in the book to the problem at hand. LLMs don't know how to do that. LLMs don't know how to read a book and apply it to a new situation because LLMs are a language model. They only know how they work. They work astonishingly well, but they're only a language model. They do not know how to do that. And again, I gave a talk at GSAS in Barcelona 3 weeks ago when we met, and I spoke then about using LLMs for architectural decisions. And I recommend to our audience when the talk comes out to have a look at it. It's an interesting talk that I enjoyed preparing.
Yeah, the recordings will be available in a couple of months, as far as I know, as far as organizers told us. Yeah, at the same conference, I was running this workshop about using LLMs for better architecture decisions. That was fun too. So what we were doing, we were like analyzing the made architecture decision records. We were analyzing the diagrams and trying to improve them on the go, and generating new artifacts like sequence diagrams and requests for comments for the architecture decisions.
And that's something that we did not talk about in this conversation at all. It's another part of the decision-making process is to keep record of what was decided, to keep archive of what was decided, and to keep it in visual form or in text form. That's a whole different topic that we did not discuss today. So first of all, Vladimir, thank you very, very much for the time, and thank you to all our audience that has been listening to us and learning from us. Vladimir, if you could in the show notes share my email address or my LinkedIn profile, so that if anybody's inclined, they could reach out. I respond to every LinkedIn message or every email I get. I'll be happy to engage with the audience. And if you have something that I said, if there's something that I said that needs correction or that you don't agree with or that you agree with but want to add a great example, then please by all means do. And I look forward to meeting some of you. And Vladimir, thank you very much for this opportunity. Hopefully we'll be able to talk again sometime, either sooner or later.
Yeah.
But thank you.
Yeah, of course. Maybe meeting you at some conference again. All right.
Next week, I am in Berlin in the ISQB conference, an architects conference in Berlin. So if anybody's there, look me up. Okay, Vladimir. Thank you. Thank you very much.
Okay. Thank you very much. Yeah. Have a nice day. See you later. Bye-bye.
Bye.